So 8051 programming can be programmed by using low-level or high-level language programming. So low-level language programming is basically written in the statements that microcontroller can directly execute. The advantage is nothing but it is a free and produce the fastest and most compactable code. But at the same time, it also has the disadvantages. To learn the 8051 assembler because it has too many number of instructions with a different format, slow to programming. And similarly, to brief in a nutshell, the assembly level language instruction set is given here and followed by the high level language programming. It uses the programming languages C. Advantages is easier to learn and it is faster to program and more compactable than assembly level language programming. Disadvantage also is there because the code cannot able to be compact as fast as the assembly level language program. Good quality of video compiler or expensive quality compilers are expensive in this context. A simple programming example is given here to demonstrate the importance of assembly level language program and the C program. So for example, if we take the C program to add two numbers, so it is defined by an unsigned character x is equal to 5, y is equal to 6 and z, where z is nothing but x plus y. If this is the code of a C language to try to add two numbers, what could be the program or the analysis of the assembly level language program would be a comma 0h, and then we'll have already moved the content, one of the content to accumulator, and straight away we can use the instruction add accumulator with the second data, and then we'll store the result into some memory location or even in the register. So any programming languages or any program in assembly level language of 8051, it will normally process or will be processed through a development cycle, and the development cycle is constrained and it is limited to an assembler having a source file followed by a macro assembler which will try to create and extract the listing of library individually and try to create an object for each and every variables and the operand which are specified in the program. Followed by we will try to create an exe file which will try to execute the corresponding code and with the programmable. There are specific general rules are available. All the codes is normally typed in the uppercase. All the comments are typed in the lowercase. When we say code is nothing but the program. Programs are typed normally in the uppercase. Of course, the mnemonics. When I say mnemonics, add, sub, mul, division, all called as mnemonics or the code. So they will be represented in the uppercase, whereas the comments are usually referred to as lowercase, and the comments are differentiated from the code with the help of a semicolon. If there is any labels are present in the instructions, it will be defined by label name followed by a colon, and then we will have an instructions. The last line of the program must be having a directive called END directive, and beginning of the program also there must be a directive called ORG directory which specifies the starting locations of the memory. It goes to that memory location and try to allot the memory, or I can say space for the particular data in which the data could be entered there. All symbols and the labels, whatever you are writing, it must start with a letter. You cannot give a label name with a number. That must be a letter. So a typical assembly program example is given here. So this is a Keil software. You have a Keil version where you can be able to see the program extension will be made as .asm. We do have a title section, and we can specify a label followed by a colon, and then we do have an assembly directives org, then we have a code comments, and then we do have an instructions where the code is been written in the program, which are differentiated with respect to each of the file segments in the program. When I write the program, immediately when I try to compile, it try to find the listing file which are produced by the assembler, so that the linker try to link the assembler and the compiler with the help of an object. So whatever the variables we created in the initial stage of the program by the assembler, every variable will have an object, and based on that object the opcodes are generated, and the opcode informations are communicated to the machine to perform the subsequent operation of that particular instruction. And for instance, if there is any addresses are specified in the instruction, that is also noted in the form of an opcode followed by an address. So when I see this particular assembler of files, this will normally consist of a code followed by an address, and the code we represented as an opcode, operational code, and followed by an address. It could be an 8-bit address or a 16-bit address which is specified there, but the data inside those 16 or 8-bit will be default 8-bit. So this is what I want to convey with respect to assembly level language program. The analysis. So there are many assembly directives we have, org, end. It could be divided into 3 segments. One is instructions, assembly directives. When I say instructions are used to generate an object file, the object instructions are not translated to a machine code. So we do have an assembler controller which defines the mode of an assembler and try to produce the equivalent listing file. So these are all some of my observation with respect to the programming of 8051. Thank you.